Yes. Yes, so we've done the reflection in the x-axis, reflection in the y-axis, reflection in the line y equals x. We have done reflection in the line y equals minus x. Now what I said, the next type of reflection is reflection in the line y equals a constant or x equals a constant. So we want to look at this reflection in the line, reflection in the line x equals a constant k, and we said the constant is y in that case. So the constant is on the x-axis, so we said it is the x-axis that is affected, is 2k minus x comma y. That's the formula. So I'm going to use that same equation there. So let's say reflect triangle ABC, that's our 2002 question there, same question, triangle ABC in the line x equals 2. So now in this case the x-axis is the one affected, so the formula says is 2k minus x. So I'll go to A6. Let me write the coordinate first so you see as we're moving. This is 1, 1 and B is 4, 2. I'll have C is 3, 7. Now I want to reflect it, so I go with A6. Remember I stopped at A5, so now I'm moving with A6 there. A6 says the K, remember here this is the K. In this case our K in this formula, in this the value for K is what is given in the question. Say reflect in the line x equals 2. The k value is 2. So anywhere you see k inside this equation, you substitute for as 2 there. So it's going to be 2 into 2 minus the x-axis here is 1 and the y-axis is also 1. So now the x-coordinate is 1. So we have the 2. So we have 4 minus 1 comma 1. So this is 3 comma 1. So A6 is going to be that. When I reflect in the line x equals 2. So I go to B6. B6, the same idea. Now B is 4. So I have 2 into k is 2 minus the x-axis for B is 4 and the y is 2. So this is 4 minus 4 comma 2. So this guy goes 0 comma 2. So I have B6 like that. So I have C6. C6, the same idea. It is 2 into k is 2 minus on the x-axis this guy is 3. This is 3 and the y is 7. So I have 4 minus 3 comma 7. So this is 1, 7. So you have C6 as that. Now I'm reflecting this, I'm drawing the image of this question. So reflect this object in the line x equals 2. So I'm coming to draw it. You see, this is 3 minus 1, that is 3 and 1, sorry. So this is 3 and 1, so it's somewhere here. This is A6 if you want. Now we have 0 and 2. 0 and 2, the y-axis is the x-axis is the 0 and the y-axis is 2, so we have that 0 and 2. This is B6 and you have 1 and 7, 1 and 7, so we have 1 comma 7. This is 7 somewhere there, so we have 1 comma 7. So you see how this guy moved there. So I go back to the point. It's 3 and 1. It's 3. It's 4 minus 1. That's 3, 3 and 1. So it's 3 comma 1. That's A6. And now we have 0 comma 2. The x-axis, the y-axis, we want to have the number. So this is 0 and 2. Sorry, this is 0 and 2, not minus 2. This is 0 and 2 here. And this is B6. So 0 and 2. Now we have this next one here, which is 1 and 7. This is 1 and we go up to 7. This is C6. So it's 0, 2, and we have 3, 1. So we go to that. We now use your ruler and you get that. This goes there. This goes there. And this other guy comes like this. So you have this. This is now reflected in the line y x equals 2. Now I want to, with the same question, let's say I want to reflect, let's say Roman 1, this Roman 2, reflect in the line, y equals 2. So I'm still on the same. So the formula we said, when I'm reflecting in the y, this time it is the y-axis that is affected. So the formula is x comma 2k minus y. So now I have A7, the x is T1, the y, the k is 2, so minus, this is 1, so this one is 1, comma 4 minus 1, so this is 1 comma 3. So watch this. This is B7. The x is t standing there at 4, and the 2 into 2, that's a k, minus the 2, that's 2 for the y. So you now have 4 comma, this is 4 minus 2, so this is 4 comma 2. That's the one for b. So C7, the seventh structure I mean. So C7 is, you go to the same formula. The 7 is, x-axis is 3, but when you go to the y, you have 2 into 2 minus 7. So you now have 3, 4 minus 7. So here we have 3 comma minus 3. So you have, this is 4 minus 7 is minus 3. So now we plot it. You say 1 and 3 is 1 comma 3. So you say 1 and 3. So it could be somewhere here. This is 1, 3, 1 and 3. This is A7 if you like. Now I'm going to use another color so you differentiate the colors as you move. So now this is A7. A7, that is 1 and A7 is 1 and 3. So 1 and 3, that's A7. And you have B7 is 4 and 2. This is 4 and 2. So this is the same point here. And you have 3 and minus 3. This is 3 and minus 3. So you have minus 3 somewhere here. This is 3 minus 3. This is C7. So you see how the triangle is being moved accordingly. So you have that. So I just use the other colors, you see what happens. So you check how it is being reflected in the line. This is reflection in the line y equals 2. So I've moved it with the blue ink. So you see the blue reflection in the line y equals that. So now we have done all the types of reflection. Remember, we said reflection in the x-axis. X is positive, y is negative. Reflection in the y-axis. Y is positive, x is negative. Reflection in the line y equals x, you interchange them. And reflection in the line y equals minus x is interchanging them, and you put negative before all of them, all the coordinates. You multiply the coordinates by minus, that's the meaning of that. And reflection in the line x equals a constant. It means that the x-axis is going to be affected, so it's going to be 2k minus x, then comma y. If you want to find reflection in the line y equals a constant, that constant can take any number. It could be 0, 1, minus 1, anything can come. So when it is reflection in the line y equals a constant, that constant is the y-axis affected. So in that case, it becomes x comma 2k minus y, because it is the y-axis that is always affected. So when it is the x-axis that is affected, when the constant that is coming is on the x, you find out that it's the x-axis that is affected. When the constant that is coming is on the y-axis is affected. So just take note of the difference over there. Now we have done the third type, the second type of transformation. Now we want to check the third type. That third type of transformation is the rotation. We still want to check the rotation. We have done this, all of them today. So we go, this is, I'll still use this triangle because this is our parent triangle today. We're going to use that to figure out all the types of transformation. So the same 2002 question, I'm still going to put it there. So you see how we go through. This is 2, this is 4. It is 1, 1, this is 1, comma 1, so that is A. And you have 4, 2, 4, comma 2. This is 4, this is B. And we'll have 3, 7, 3, 7. So we'll have C. So it's C, the same triangle, the same 2002. So you watch out. Now I'm going to the third type of transformation. The third type of transformation is rotation. That is C. C is rotation. Rotation. Now we can rotate this. We can rotate through the following. We have force. I can rotate clockwise rotation, and then I can rotate anti-clockwise. So we can rotate clockwise and anti-clockwise. So in this case, I will just demonstrate with this ruler. So I can rotate this ruler clockwise, anti-clockwise. If I go clockwise this way, I rotate this ruler. I'm going clockwise that way. So I want to rotate that clockwise. This is clockwise. This is how the hand, the minute hand of the clock goes. So it's clockwise, and this is anti-clockwise. So I can rotate it anti-clockwise this way, or I rotate it this way. So here, this object is going to be rotated either clockwise, anti-clockwise this way, or I can rotate it clockwise the other other way. So you see what is going to happen here just now. So let's run through it. We have for clockwise rotation at 90 degrees, you can rotate the object through 90 degrees. Let me just give an example here. Let's say I have this bottle. This is the bottle. Now I want to rotate the bottle 90 degrees. This is north, this is east. This is 90 degrees. If I want to rotate it 90 degrees clockwise, this is clockwise rotation. And this is anti-clockwise rotation. This is anti-clockwise. So if I want to rotate this bottle clockwise, I expect the bottle to drop this way. The bottle will be there, this is the way it will drop. Because if it was standing this way, then I rotate it clockwise, it goes and fall that way. That is clockwise rotation. It has gone through the clock. Now that's 90 degrees. Now I can also rotate it anti-clockwise 90. It can go this way, anti-clockwise 90. So you expect the bottle to be like this. When I drop it anti-clockwise, so if I drop it anti-clockwise, this is how it will go, yeah, and this is clockwise this way. So how will this bottle go clockwise 90 degrees and go anti-clockwise 90 degrees? I'm going to give you the formula just now. So clockwise 90 degrees, it is y comma minus x. Now the clockwise rotation 90 degrees, the y coordinate starts, because if I'm trying to rotate my body, my vertical portion of the body is the one that is going to move first. Because if I'm supposed to rotate, I have to rotate with the upper part of my body, and the upper part of the object is the vertical plane. So it is the y that moves straight before the x follows. So in the rotation 90 degrees clockwise, it is the y axis that starts with the coordinate. So now we go to the anti-clockwise. The anti-clockwise is this way. So here for anti-clockwise, so I'll just be putting them together as we move. For anti-clockwise 90 degrees, you have anti means opposite of the clock. So if the clock here is positive y, so this one becomes negative, and here is negative x, so it becomes positive over there, because anti means opposite of the clock. If the clock is y minus x, then the anti-clock will be the opposite of this. So now we have the next type of rotation is 180 degrees. 180 degrees is I want to move this object here 90 degrees, then it comes here 90, so that is 180. So when it dropped that way, I expect it to drop this way. It's supposed to be in this direction, so the bottle will be there. So for this bottle to move, let's say this is the base of the bottle, so for this bottle to drop there is 90, and now 90, this is 180. So 180 is clockwise, whether I move here clockwise to 180 or anti-clockwise there 180, you find out that the bottle is still going to appear in this position. So if I'm moving here, I move clockwise 90 degrees, then I rotate it again another 90 degrees, so it becomes 180 there. Or I rotate it this way, anti-clockwise, I go 90 degrees anti-clockwise, then another 90 degrees anti-clockwise, I'm still going to have the same position. So that is why we don't have clockwise 180, anti-clockwise 180. Both of them have the same formula. So you have minus x comma minus y, and here also 180 degrees anti-clockwise is minus x comma minus y. So the formulas are the same, because anyhow you move this bottle, let's say this is the bottle, I'm moving it, I'm rotating 90 degrees there, so it goes there, and this is another 90, so it is 180 there. So I'll still appear here, that is clockwise. So that's this formula. So if I have to move it the other way, it's going to be there, and there again. So you find out that either I go this way, it's clockwise, or I go the other way, anti-clockwise, the same position. So the formulas are all the same. So I go to 270. In 270, in rotating 270, you have 3 ways you can do that. Let me just use 270 here. I give you 3 ways you can move that bottle. So it is 270. It's enhanced in 3 ways. You can do the 90 approach. So this is 90 plus 90 plus 90. It is still 270. Or this is, I'm just trying to give you an example of this. Or you say 180 plus 90 is still the same, or you do anti-clockwise. So you have 3 ways you can move 270. You can rotate 270 3 ways. First, you can rotate 90 twice. So let's say I want to rotate this point. This point is 3, 2. I want to rotate this point 270. So the rule says you are going to rotate it first 90 degrees, so it becomes 2. The first 90 degrees, it becomes 2, 3. Yeah, so I go again to the next 90. Now the y must always come in front, so it's going to be the next 90 will become 3, 2, and the last 90 will become 2, 3. So the last position is going to be 2, 3. That is what is here. Now we come back for 180. 180 says you move it 180 and 90. This is minus, it's supposed to be minus x, so it becomes here minus 3 comma, this is minus 2. That is for 180. Now it says rotate it now the other way. So you have this first, let's start with this. This is, I'm rotating this point. Let me repeat this one again. So I have a 3. So let me start it fresh so that I want to do two different numbers. So we have the 3 formations here. I said A, B, C. So I want to use a complex one using a number that has a negative. So I make it complex here. So now we have one of them that's negative, the other one is plus. So I use this. So this one says 90. If I use the 90, I'm going to take the x, the y is going to be minus 2, that is for the y over there, and the x becomes a negative, so this guy becomes a negative. This is 3. All right, no problem. Now we go back to the next 90. 90 says bring the y again, so we bring the y from here. This is minus 3, and you put negative on the x, so it's going to be minus 3. Now the x is there, that negative by that negative will give me the plus, so this guy becomes plus. So I've done 190, another 90. Now I'm going to the last 90, the same formula. It says bring the y, so I bring the y, and it says put negative on the x, so I put negative. If I put negative here, this guy becomes plus. So the final answer is the 2 commas there. So I come back with this guy is, it says put negative between put x negative and y negative, so I bring that. It's going to be minus 3, that is for the x, and I bring negative for that, it becomes plus. That is for the 180. He said then rotate it again 90 degrees. 90 degrees is y, bring y and put negative on the, so I bring the y becomes 2 and put negative before the minus 3, so it becomes plus. So it means, so it gives you the same answer here. Or I use this formula on the same guy here. It says bring the negative before the y is minus 2. I put negative before it becomes 2, and I bring the x is 3, so I put it here. So it is either this, the same answer. So if you are doing 270, you can do 90 consecutively, or you do 180 plus 90, or you do anti-clockwise 90 degrees. This will give you the same answer. So this is optional for the students. You can, when they say rotate 270, you can rotate in all 3 fashions here. That's why you're not limited in the exam, so you try to do that. So that is rotation for you. So now we want to look at the last part of reflection. So we want to look at how this guy is rotated. So for instance, since I've given you the formula, I want to use the same equation, the same structure there, the 2002, and see how it is rotated. Let's start with rotation 180. I want to rotate 180, rotation 180. So that guy says we rotate it 180 is A8. If I want to go now, A8 becomes minus 1, so B8 becomes minus 4, minus 2, and C8 becomes minus 3, minus 7. This is the plot. So we see it's minus 1, minus 1, minus 1, minus 1. This is A8, minus 1, minus 1. And we have minus 4, minus 2, minus 4, minus 2. This is minus 2 here. This is B8. And we have minus 3, minus 7. This is minus 3, minus 7. This is C8. So you can find out that this is, you have seen that this triangle has been rotated 180 degrees. It was there, then it went 90, then now 180. Or I go this other way, it is T 90, then 180. So that is rotation 180 degrees. So that's how it is affected. So I can rotate it. I want to rotate it still 90 degrees. Let's say rotate 90 degrees. 90 degrees. I'm rotating it 90 degrees. The formula says now this one. So this it says there. You rotate. The formula says 90 degrees is y, comma minus x. A9 becomes bring the y. You say bring the y. The y is 1 and minus 1, and B9 is bring the y is 2 and minus 4, 2 and minus 4, yes, and the C9, according to this is a ninth diagram, that's the meaning of C9. Then you see bring the y is 7 and minus 3. So we have we now plot is 1 minus 1. This is 1 minus 1. That's somewhere there. And you have 2 minus 4. This is 2 minus 4. That's somewhere there. And you have 7 minus 3. 7 minus 3. That's somewhere there. So you go there and there and there. So you have seen that this object has been rotated 90 degrees clockwise there. So that is why you have C9 somewhere. So that C, the C up there has moved to that point. So this is C, it has been rotated 90 degrees clockwise. So now I've basically given you all of them. So let me go to the fourth type of rotation, which is now the fourth type of transformation. I've done all of them. So I'm going to do the last type of it, which is the enlargement. So watch out for the enlargement. I still use my structure here to do the enlargement. I'm going to use the same structure and do the enlargement. So we have the scale factor. The scale factor is this D. We have done transformation, translation. I've done reflection. I've done rotation. So the D is now enlargement. What is enlargement? Enlargement is make bigger, to make bigger. In making bigger, then you need the two types of enlargement. It's enlargement from the origin, or enlargement from a point. Enlargement from a point. So we're going to emphasize much more from enlargement from a, and requirement for enlargement. The requirement includes one, you need a center for enlargement. You have the center, and you need number two, you need a scale factor. So now we are going to enlarge that object so let me just say enlarge is to A2, so enlarge. So our example is going to be enlarge triangle ABC to A1, B1, C1 from origin using scale factor of 2. So when you are enlarging the object, if it is enlargement from the origin, not from a point, you have two types of enlargement, A, B there, and this is from a point. If you are enlarging from the origin, anytime the question says enlarge from the origin, remember all our rotation has been about the origin. So we are also going to enlarge the object about this origin. So when I'm enlarging it about this origin, if the question says enlarge about the origin, you are required to look for the center. So the center is, when they say the origin is the center, you are enlarging around about the origin, then the center becomes the intersection of the x and the y axis. That is the point where x is 0, y is 0. That's the origin of the graph here. So we are enlarging about this center. So the center is already there. But in this question, we need the scale factor. The scale factor is 2. So when you are enlarging around about the origin, you only need to do the following. So let's say A1 will become, just multiply. The procedure is you multiply all the coordinates of the object by the scale factor. So in that case, if we are enlarging this A is 1, 1. Let me just put the object here so we can see it clearly. This 1, 1, and B is 4, 2, and you have C is 3, 7. Now I want to enlarge it to A1. So it says you multiply all of this by the scale factor. Multiply all by the scale factor, and the scale factor is 2. So I'm multiplying all this coordinate by 2. So now we have, this is 2, because 2 times 1 is 2, is 2, and this is B1 will become 8, 4, and C1 will becomes 6, 14. So now let's see our scale has been prolonged. Let's say we have 8, yes, and we have 6, and we have 14 somewhere. So let's say I have 12 here, then I have 14 somewhere there. Now I want to show the enlargement of this. So it is 2, 2. So this is, I use another color so that you see, this is A1, 2, 2, and we have 8, 4. This is 8, 4, 8, 4. That is B1. Let's say, and C is 6, 14. This is 6, and we have, let's say, 14 somewhere there. So if I could just use that position, so we can now connect this point to this, and now here to this. So you have seen that it has been enlarged to, this shape has been enlarged to a bigger size. This is now being blown up, from the object has been blown up to that size. So using from the origin. So this is how enlargement is effected. You enlarge the object, from the object becomes blown up, and you see it there as you see in the question. So now those are the 4 basic type of transformation. Remember, I'll give you a summary. We have said reflection, we have said transformation, translation is another form of transformation, and we said reflection in all the axes, x and y, in the line y equals x, we did all of that, and we have rotated about the origin 90 degrees, 180, 270 even, and now we came to enlargement from the origin. Remember, enlargement from the origin, you need a scale factor and also the origin for enlargement. When you are enlarging from a point, you need to enlarge just from that point. Let's say I wanted to enlarge this object from this point. For instance, let's say I have a bottle, say over here. Now I can now use this example. I want to enlarge using from a point. Let's say the bottle was standing somewhere there. This is my bottle and it has been enlarged. Yep, this is enlarged from that point. Now it has been enlarged to this. Now if I want to know where the enlargement took place, let's say I have A, B. So I still have A1, B1, and C is C1. This is D, D1, and D. Just to get that. So now I want to know whether these two objects, this was the object and this is the image, it has been blown up, but I want to know the position, which point it was enlarged from. So I want to know whether it is enlarged from another point other than the origin. If it is from the origin, then when I project these lines, it must touch this origin. But let's say I want to know the point where this object was enlarged. Let's say it has been enlarged. So what you do, you take your ruler and you try to connect this point. So from here, let's say you connect image point to object point. So I connect this here to somewhere there. Then I connect C to C, C to C1. So we can see that these two lines met somewhere there. So I want to now know where this guy was enlarged. So I'll read here this -2. And this is -4 in that order. So if I read this point, this is going to be -1 and 2. So this was the center where it was enlarged. So if I want to get a coordinate, it's supposed to be -1, -2. So the enlargement took place from this point. So enlargement from a point other than the origin, you have to, let's say the structures were drawn, this one was enlarged to this, but you don't know where the enlargement, the point to which the enlargement was emphasized. So you have to connect the image point to the object point and you extrapolate backward. These two lines will meet at a point. Any two lines here will meet at a point. That point is read in the graph paper. It will give you the point where you stood to enlarge. But when it is from the origin, if it is from the origin, you will find out that if they say this was the object here and now it was enlarged to that bigger object somewhere there. Now when you project this image to that and it comes up to that point, then you now know that this is 0. It means it was enlarged from the origin. This is enlarged from origin, and this is enlarged from a point. There's a point inside the graph paper you must be able to locate. So that is how you project it and get. You can even estimate the scale factor here. Maybe this object you have drawn, this was a bottle, and this other bottle was also drawn. This was blown to this. This is the image, but you don't know what is the scale factor. Let's say it was a question like that. So if you want to know what is the scale factor, you are going to use magnification. You know magnification. This is in physics. You know that magnification. That's the object image distance. You have image distance over object distance. So the image distance, let's say you stood from here, you measure to that length over there. Let's say from here to that image, from the center to that image is 8 centimeter. Let's say it's 8 centimeter. Now, and you measure from the object position to here, you also measure from here. Let's say it is 4 centimeter. So this distance divided by this distance will give you the scale factor. This enter here will give you the scale factor. That is magnification. Magnification is image distance over object distance. So we can also apply physics here to get the scale factor if the object and the image are drawn on the question question paper and you are asked to find the scale factor and even the center of enlargement. So watch out for that question. It's a strange one, but it's highly possible. So this is how you figure out the enlargement procedure. Now I want to take one last question with Dr. embed all of these facts I have just explained for you here. So you give me some time, let me just write the question so that we go with that quickly.